get started with essential physics. Over the next 90 minutes, I hope to show you the fundamentals of our essential physics program, which is a combination of curriculum and equipment. And here's the agenda for our time together. I'm first going to kind of dive into our resources and give you a feel for the program with an overview. And then we're going to kind of pull back and look at each of the components in a little more detail. We'll start with the student textbook and corresponding electronic version, the ebook. Then we'll take a look at the numerous teacher resources that are available to support your teaching as students are using the textbook and ebook. And finally, we'll take a look at wrapping this all together through an investigation, and I'll demonstrate how this investigation can be done. It's designed for student use, so be sure to to ensure that you know where all the resources for you, the teacher, are to help your students succeed at this investigation. So that's the outline of our time together today, and we invite you who are here with us live to ask questions as we go throughout in the Q&A panel. So first, an overview. What is Essential Physics? Well, this is the third edition of our Essential Physics program, and I'm going to just talk through the components very quickly here, and then we're going to kind of dive into an example to give you a better concrete feel for it. Fundamentally, there is a student textbook. You can see a copy of it here through the live video. By the way, if you're joining us live, you can change the relative size of the video and my screen sharing if you wish to emphasize one over the other. The student textbook is a about 875-page textbook, full color, and we'll be looking at some of the resources in that book shortly. But the nice thing is this corresponds to an electronic version of the textbook. We'll learn more about that shortly, and I will mostly today be projecting that ebook because you can see it much better certainly than my shared document camera view here. But I want you to know there is a physical textbook in this program. There's also a teacher ebook, and the great thing about the teacher ebook is that it's filled with resources for you, the teacher, to use with your students as they work through the content of the course. We'll be looking in more detail. Some of those resources are in the book itself. Others are on the website accessible with your login for the book, the teacher book. One of those resources that we'll dive into today is the Infinite Test Bank, which allows you to create exams for your students based on the topics across the chapters of Essential Physics. And another resource is the PASCO Physics Academy. We'll look at that more shortly, and you'll get some idea for the resources that we have there. But fundamentally, it's kind of a set of videos, some for you, the instructor, others that you could use directly with your students in certain circumstances that might be useful if you're not able to do the teaching yourself. All right. There are also equipment kits that go with Essential Physics. We're going to see shortly that hands-on investigations are fundamental to the book and integrated in the book. So we're going to use some equipment from those kits today. I'll also point you to some more resources for learning about those kits. And then some key components in those kits, like the smart cart you see here and the sensors for voltage and current and magnetic field that you see in the background, are used with our SPARKvue software. SPARKvue is available across many platforms. So as part of our session today, you'll get an exposure to SPARKvue and some of the ways we can collect and analyze data in SPARKvue. All right, so first let's kind of dive in here. I'm going to look at the book itself, the physical book, shortly, and just wanted to show you how much the hands-on investigations are integrated. So if we start on page 1 and we're in chapter 1, it doesn't take very long before we get to page 5 here, and we are looking at the first investigation, the first hands-on investigation in the book. So you can see both the physical book here and the corresponding page in the electronic book that I have a screenshot of. So this, let me go ahead and bring up this page so that you can see it a little better. Go into the student book here and go directly to page 5, where we can see the correspondence between the physical book and the ebook for students here. And this is already on page 5 is a hands-on investigation for students to explore graphs of motion. And you as the instructor may say, this looks interesting. Hopefully your students say, hey, are we going to do that? And so early in the book, you may be having some questions like, wait, my students don't know about position and velocity yet. I'm only on page 5. And what does it mean to open this experiment file and connect the smart cart and all these questions? So what I want to ensure you is that there are a lot of resources for you, the teacher, to get familiar with this activity and help your students get familiar with it as well. So I'm just going to graphically on the slides here show you what some of those resources are. And then we'll walk through this activity very quickly to get a sense of some hands-on experiences that students can have. So for the corresponding page 5 in the student book, there is a teacher ebook page that has some additional resources. I'll highlight some of those resources right now, and we're going to dive into these in much more detail when we get to the teacher book. But one of those is a lesson plan. This is going to help you determine, well, what's the context for this? Why are they doing graphs of motion in chapter 1 here? There's a corresponding video that is one of our PASCO physics instructors speaking directly to you the physics teacher, saying, well, you know what, the context for this lab is not students learning about position and velocity graphs. It is using their more basic interpretation skills of graphs in general versus time, and getting familiar with some of the key equipment they're going to use, namely the smart cart that's going to play a role throughout essentially the first half of the book as we do kinematics and dynamics. And this activity, the key points, are also demonstrated in this video that is included in the teacher ebook. Now, there are requests here in the lab itself to do things like connect the smart cart and open this experiment file. The video covers how to do that, especially knowing that you are probably new to the program so early in the book. And it actually has slides that you can show to students saying, hey, here is the buttons you press to actually connect to the cart. So we have supports built in for you to learn yourself, and supports that you can use to help your students learn. Finally, you'll notice in the lab itself, there are some questions. As students are collecting data, they're asked to respond to some questions. Well, where should they respond to those? One of the additional resources in the teacher ebook is a student assignment handout with places for them to respond to those questions on paper or electronically. Finally, there is an answer key that corresponds to the typical or expected responses for that. So knowing that these resources back you up, I'm just going to dive into it and assume that we've gotten some more information from these resources and do a little bit with our smart cart and SPARKvue so we can get a feel for the capabilities of that part of the program. So the lab itself says that we're supposed to open an experiment file and then connect the smart cart. Well, we saw that there are resources that can help us learn how to do that. I'm just going to show you by jumping over to our SPARKvue software. SPARKvue is featured throughout essential physics hands-on experiments for connecting to our sensors and collecting and doing data analysis. Well, the first instruction is to open a PASCO experiment, and there's a dedicated button in SPARKvue for that. So go ahead and open the PASCO experiment, and there's a dedicated folder of essential physics labs, and we can see there are setup files across the entire book when we have labs that use PASCO sensors. So this is 1A as indicated by the instructions to students. I'll go ahead and open experiment 1A's file, graphs of motion. And these files are intended to get your students quickly collecting data. The students just need to open the file and connect the sensor, and then the displays that are needed for the particular experiment are configured. The rate at which data is being collected is configured. So we hope this allows them to dive quickly into the data collection and the real meat of it, the analysis and interpretation of that data. So we've opened that file. We need to now connect our smart cart. The smart cart is an example of a wireless sensor. It looks like a cart, but it actually has a suite of sensors built into it. And if we want to connect wirelessly to the sensor, we just need to turn it on by pressing its power button. When we do that, the battery light briefly illuminates, after which we should see that there's a Bluetooth light blinking. So this is the key to making wireless connections with the sensors. It uses Bluetooth 4 or Bluetooth Low Energy. And the beauty of that version of Bluetooth is that it allows us to connect directly inside the software. We don't need to dive into the particular control panels for our operating system. I happen to be using SPARKvue on Windows today, but we're going to learn later this is available and connects to sensors the same way on a variety of devices in the classroom these days. So it's a Bluetooth device. I'll click on the Bluetooth button, and my computer and SPARKvue are now looking for available PASCO sensors. It finds and identifies that smart cart that I've just turned on, and hopefully you have many of these in your classroom. If that's the case, the one that's closest to your computer is going to show up in the top of this, at the top of the list, and you can always confirm that by looking at the corresponding 6-digit ID on the smart cart itself. I see that this 6-digit ID shown in SPARKvue matches that. So I'll click on it, and SPARKvue is going to make that Bluetooth wireless connection to the smart cart, and then it will be mine, not available for any other students to use. All right, the smart cart moves up into connected devices. And this particular activity is just an exploration for students to get familiar with the smart cart and begin asking questions and interpreting graphs. So it's going to ask us to start data collection and move the smart cart back and forth on the table and watch how the position and velocity graphs already configured for us in SPARKvue change as we move the cart. So let's go ahead and do that. You should be able to see both my live cart here and the graphs of position versus time on the top and velocity versus time on the bottom. There's a nice green start button here at the bottom that allows me to start collecting data. As soon as I do that, you'll see data points begin to populate these two graphs, and I can move the cart back and forth and begin to interpret what's happening here in the graphs of position and velocity that we see. All right, so that's the initial exploration. We're going to learn more about the tools available in SPARKvue. In the graph, there are many tools available for analyzing, annotating, and changing our view of data. They live in the graph toolbar down here, and I can open the toolbar by just clicking on this button, and it expands and shows me some tools. Probably the first tool I'd introduce is the scale to fit button. Whenever I press scale to fit, it's going to automatically adjust the axes of the graph to ensure that my data is filling the screen and I'm getting the best view of that data. So we can see when I was not moving the cart, when I was moving it forward, stopping, moving backward, and so forth. Now, the lab itself is going to have students do that and then start to ask them questions like, if you push the smart cart across the floor and let go, what happens to its velocity? Well, let me go ahead and put it on the table here, and I'll try that. Heading back to SPARKvue, how do you collect another run? Well, you just press start again. So I'll press start and push the cart across this table. Interesting. Go ahead and press stop. I can scale to fit that as well. And students can begin to interpret, well, this is position. So the position increased and then eventually it stopped at a particular position about 0.7 meters from where it started. And here's what happened to the corresponding velocity. Again, not a lesson on position velocity, but a first introduction to the importance of interpreting graphs. This activity then has students do various things. And I kind of like this last one here. It asks students to ask themselves, how does a smart cart actually track motion? Well, try spinning each wheel with a finger. I'm going to head back to SPARKvue, and this is one of the questions in this activity that has students begin to analyze what's actually happening with the technology we're using here. So if we turn the smart cart over, you'll see that there are 4 wheels, and the lab suggests students spin these wheels. So let me go ahead and spin this back left wheel from my perspective. Nothing happens there. And I can actually see that also spins this. So it looks like they're connected by axles. I'll go ahead and spin the front wheels. Hey, looks like that is how the sensor is actually measuring its position. And I can see one direction is a positive velocity, the other direction is negative, and that corresponds with our discoveries when we're moving it back and forth. So begin to introduce students to both the technology and the science information we can get from that technology. Well, this particular activity goes on and has them kind of prove that they understand position time graphs by matching particular shapes shown here, and then begin to apply forces. The smart cart, besides being able to measure position, velocity, acceleration, can have accessories attached, and we'll see that at the end of our time together for measuring forces. So you can see that one of the goals of essential physics here is to get students using sensors and doing hands-on activities, interpreting data right away, even as soon as page 5 on this. All right. Now, I showed you some of the things, but hopefully you're comfortable that those things exist for helping you, the teacher, learn this stuff in the ebook itself. So, yes. Okay, thanks. All right, I'll try slowing down a little bit. All right. So that is just an example of one investigation. Hopefully, if you are using this book, by the time you get to, say, page 8, and see that there's another investigation on musical sounds, you can say, hey, I know where to get the resources for that. So page 8 kind of jumps away from the smart cart for a moment, gives you an overview of the importance of waves in physics in this overview chapter. And of course, there are corresponding resources in the teacher book. But what's unique about this investigation compared to the first one we did is that it is an interactive. So the teacher resources will show you how to use this, but let me jump over there and show you how the activities that are interactive in the textbook work. So I'm going to jump back over to the student book and jump directly to page 8, which you can see physically here as well. And this is another investigation, investigation 1B. However, this doesn't use any physical items as the first investigation did. Instead, there's an interactive simulation. So if I click on that simulation, again, student instructions are available for this. But hopefully, if I have Zoom set up correctly here, you should be able to see and hear that we can see a waveform. Make that a little more melodious. I'm going to turn on just this C note. And are you able to hear that? All right, thanks, Cal. All right, and this has students asking questions like, well, what's the difference between the notes? What changes in terms of this graph of pressure versus time as you change the notes? We can go through and change the frequency. I'll go ahead and turn that off. I'm sure there's some interference on Zoom at the moment, but some of the investigations in our book are interactives like this, when it's not reasonable or it's more reasonable to use something that is virtual, and others are physical, like the first investigation we saw. But I hope this highlights some of the resources in both the teacher and student books and the importance of these investigations in the book. Just a little preview. Kel, before we proceed, are there any questions that we should address about the things we've done so far?
Question about friction and slippage. The question is, if there is enough friction in the wheels, the sensor would not read correctly.
Yep, that's a good observation. So the wheels themselves have an optical reader on them, and the question was about slipping. If these wheels were to slip, they wouldn't be able to detect their change in position. I'll tell you, I don't have much experience with them slipping, whether I'm using them on the hard floor or the tabletop that you saw here or the track. So not something I've experienced, but you are correct. That is a requirement that these wheels don't slip in order for the measurement to be valid. Thanks for the question, Sergio. All right. So let us move on then and start looking at these components. The first component here that we're going to focus on is very briefly the student textbook. This is the physical textbook. We've already seen it here, and 870 some pages long. Because you can't see it particularly well, I'm not going to spend much time on it, but this might be a good time for me to talk about the structure of the book in the table of contents, and I'll show it to you here on the slide for a little better way to interpret it. The Essential Physics program comprises 8 units, and these 8 units are in a fairly traditional sequence, and you can see the chapter divisions among those. It's a fairly traditional sequence for general or honors level physics at the high school, that is secondary level. So a couple of unique things. One is that in order to emphasize the hands-on nature, you may notice that instead of introducing electric and magnetic fields in the theoretical point charge way first it has students getting some hands-on experience with circuits, for which we have some nice hands-on equipment in the form of our modular circuits kit. Otherwise, it follows a fairly standard sequence. Of course, you may have your own preferences and can remix as needed. All right, so that's the textbook organization. So overall 8 units, 27 chapters. As we're going to see shortly, there are 2 to 4 sections inside each chapter. One of the things this textbook emphasizes is chunking things into digestible bits for students to digest. And then, as we've seen, there are investigations built into the book, including 8 of those being engineering design projects. All right, well, we can't see the textbook particularly well, so we're going to jump over to the ebook, and I feel justified in doing that for the following reason. How does the ebook relate to the textbook? Well, the great thing is that if you find a page like 531, say, in the textbook, if you go to the corresponding page in the ebook, 531, it's going to look exactly the same. So all of the content of the physical textbook is available in the ebook. So it matches it page for page. However, the ebook goes beyond that. The ebook is not just a PDF of the textbook. It has interactive elements that we're going to explore shortly. And it runs in any modern browser. It's essentially HTML5, so you do not need to install any software to use the book. Any browser on any device that has a modern browser will be able to view the textbook. And that includes the phones in students' pockets, tablets, and full computers. All right, so key question here. Well, how do students get to this book in their browsers? Well, it is browser-based, and to get to the book, they're going to go to the website education.pasco.com. So let me bring up that page and show you what it looks like. When anyone goes to education.pasco.com, they're going to be greeted by our 2 textbooks here, Essential Physics and Essential Chemistry. And there are some background information here, some orientations, equipment kits. But in order to actually access the book, the students are going to have to enter an access code right here. So a little bit more about the access code. It's a long alphanumeric string. This isn't a real access code, but it kind of represents, it's a series of letters and numbers. And in the middle of it, you're going to see something like EP3 for Essential Physics 3, SB for student book. Those will be the cues to you that this key is for our Essential Physics book and it's for students. Now, for the sake of not having to you juggle a bunch of student logins, we don't care which students are using it. If your school or your district adopts essential physics, you will get an access key for students, and it'll be for a specific number of students, say 500 students in your district for a certain number of years, often 5 to 7. And that key will be valid for 500 students simultaneously using the book. And if student A loses the key, they can just ask student B because that key is shared between all students. We say it's for simultaneous student use. That's because if you've adopted for many years and you have 500 seats for this, the students who go through physics in year 1 of your program are probably moving on beyond physics. That means those seats are open for 500 new students the next year. All right, so that's how the access code works. I am already logged into the student book on a different browser, so I'm going to bring that over to show you that once you type in the access code, students, if you type in a student access code, are going to see a couple of options: sign out or actually open the book. So students get to the book via education.pasco.com and enter their access code. By the way, this is saved as a cookie, so the second time they go there on a particular browser, they're not going to need to re-enter that access code. So let me go ahead and open the book, and we get to the student book's homepage, as we call it, which has a list of navigation buttons here. So let's go ahead and look at the navigation. We've already seen a preview of this. I showed you that I can jump directly to, say, page 5, where I know from the physical book that we have an investigation 1A. So from the homepage, we can navigate directly to specific pages. And of course, because this matches the physical book, it doesn't really matter if your students are in the physical book or on the ebook. You can say, hey, today we're looking at page 120. You can just jump there directly, whether you're using the physical book or the ebook. Another way to navigate the book from the homepage is the contents button. This gets you to the table of contents, just like you can see in the book. And for this preview of the ebook's contents and navigation, I'm going to use chapter 4 on acceleration. And from the table of contents, I can navigate directly to the page 106 by clicking on it here in the table of contents. And of course, this is going to correspond to what we see in the physical book, page per page. Now, I'm going to kind of de-emphasize the physical book now, but in the first pass through the ebook, we're going to focus on things that are common between the physical book and the ebook. That is, what is the structure and what content is common between the two before we extend this into what is novel about the ebook in terms of interaction. So first pass, let's take a look at the content of chapter 4 and see how it's structured, whether it's the physical textbook or the ebook. So each chapter is going to begin with a page that tries to engage students in the topic in some hopefully interesting real-world context, in this case, acceleration in the context of planes and roller coasters, for example. Now, I want to navigate around the book, and I have to do that in the ebook here. A couple things to note. This is just in a browser, so you can always just use the back and forward buttons of your browser itself to go to the prior page in history and go forward to the next page in history. But when you're going page by page through the book, you're probably going to be using the back page and forward a page button, which are available at the top of the page, also at the bottom of the page. And for convenience, the left and right arrows on your keyboard, if you're on a computing device with a keyboard, allows you to go forward. So I can either hit the right arrow to go to the next page, or I can hit the right arrow on my keyboard to do the same. I'll go ahead and use the keyboard, I'll use the arrows up here so you can see what's happening instead of assuming I'm hitting the keyboard. So on page 2 of each chapter is a chapter study guide. Essential Physics is designed kind of with the end in mind, so it gets students thinking about what the goals of this chapter are as they're studying acceleration. It begins with a chapter summary, includes some learning objectives. By the end of the chapter, students should understand the following. Includes the number of investigations that are included right in the book, as we saw earlier for chapter 1. Chapter 4 is the same. There's a chapter index, and you may notice right away each page has a chapter index. We'll talk about why shortly. This is an algebra-based textbook for physics, so we see the important relationships, algebra expressions here for this chapter, and finally the key vocabulary introduced in this chapter. So the chapter study guide is the second page of every chapter and includes these common elements. All right, continuing in the ebook, if we go forward to the next page, this will be page 108. Here we see the actual beginning of the content. And I want to call out some of the structure of each of these pages. First off, we are in the first section of chapter 4. So I can use this button up here to see I'm in chapter 4, section 1, 4.1. And if I click on it, we can see chapter 4 consists of 2 content sections after the study guide. Section 4.1, acceleration, section 4.2, gravity and free fall. So whenever we see a green title, we are starting a new section of the book. And The blue title on the top of each page indicates the single concept of the page. So the first page here is covering what is acceleration. If I go forward to page 109, I see that there's a single concept on this page, acceleration of motion graphs, and continuing understanding acceleration and so forth. So the book tries to introduce just one concept per page. Similarly, it breaks things down by paragraph. There is a topic description on the sidebar of every paragraph, so students can either quiz themselves after they read it if they understand that concept, or it's great for scanning the book afterwards to find particular content sections. All right, so that's the structure of the book. We have units, chapters, and then within each chapter we have sections. Each page itself has a single concept, and each paragraph has a topic as called out in the sidebar. All right, let's go ahead and move through the book a little bit and see some other characteristics of the book. If we go forward here to page 112, we see worked problems, especially in physics class, getting students to understand how to respond to a problem and essentially developing a sense of how to respond to those questions is key. So we break down the questions as we suggest students should, figuring out, well, what is asked by this question? What are the givens? What relationships have I learned so far that would be relevant? And then how can I use those relationships and the given parameters to answer the question? So it tries to break down these problem-solving techniques that we learn as we go through the physics course by being explicit about calling those out in the example problems of the book. All right. So we'll continue moving through the book here. When we get to this page, page 120, I want to call out the correspondence that the book attempts to make between the math used in physics and the math that students may be learning in an algebra course. This example is trying to make the correlation between the format that they're learning for quadratic equations in the math class and the corresponding use of quadratic equations, for example, in the equation for the position of an object under constant acceleration. So you're going to see throughout the book attempts to make correlations between the math and the physics, so students know how that math is being applied in their physics course. Right, go forward one page. We saw that the chapters rather are divided into sections. This is the end of section 1. Every section in the book ends with a review, which states in text what the main concepts were, reviews the vocabulary and the key equations available, and then provides some formative assessments for students to determine did they get the key concepts through the form of some problems and questions at the end of each section. So every section is going to end similarly with a section review with these components. Now, I'm going to jump to the end of this chapter. There are two sections. I can do that by hitting the problems button, and it's going to jump me to page 127, which is just after the end of section 2. It is the chapter 4 review, and we can see that there are end of chapter problems. They are divided into sections, section 4.1, 4.2. They're also divided by type. So there are vocabulary questions, there are conceptual questions. And if we move forward a page, we'll see that the questions are also kind of ranked by difficulty as indicated by a number of chilies. So if we see questions 22 through 25 here, they are of increasing difficulty from 0 to 1 to 2 to 3 chilies. There's also quantitative problems. And finally, when we get to the end of these problems on page 131, you'll see that there's some standardized test practice questions in the form of multiple choice questions, formatted like they might be on a typical standardized test. All right, so that is the chapter overview, the structure of the chapter, and some of the key content in it. Keller, are there any questions we can address about that structure or content before we move on? No, thanks for answering those questions I see in the Q&A. All right, so I want to call out that we've looked at some of the components of the chapter navigation bar. We haven't looked at all of them, though. So now we're going to talk about navigation that's unique to the ebook. We've looked at the home button chapter. We can jump to particular pages. If we jump over to the end here, this book, as we saw, tries to integrate concepts like math concepts. And if you click on either any of these buttons, science, technology, engineering, or math, you'll see the connections made in that chapter between those topics and the physics introduced. So for example, if you're interested in where are quadratic equations addressed, we can go to the math button and go directly. Notice that the content that corresponds to that link is highlighted in yellow when you go to that page. So true for science, technology, engineering, and math, or STEM concepts. The problems in the book, you might have noticed, we can get to directly to the end of chapter problems by hitting problems, and then we can get directly to the investigations in the particular chapter by clicking on investigations, and it's hyperlinked to the investigation page. Now, there's some content in the ebook that, of course, can't be in the physical book, and those include videos, either animations or live videos that are embedded in the ebook, and also interactives. And we're going to take a look at more detail of video interactives in the next pass through the book. For now, though, I just want to go back to the homepage and note that from the homepage, there are many similar navigation buttons. The difference here, though, is that if you click on, say, investigations, when you're on the homepage, instead of showing you only the investigations from the current chapter, it shows you the investigations from across the book. So this is a quick way to jump from the homepage to any particular content across the book. All right, so that is the keys to navigation in the ebook, whether from the homepage, book-wide, or from a specific chapter. So again, the chapter opener begins every chapter. Second page of the chapter is a study guide. We have one topic per page and one concept per paragraph. Every section ends with review, and every chapter ends with review questions. And that, of course, is repeated across the chapters of the book. So, as I've already alluded to, there are interactive features that the ebook has that, of course, the physical book can't. If you have access to Essential Physics and are watching the recording, I'd encourage you to pause it at this point and challenge yourself to try to locate the following interactive features. I know some of you don't have access and we're live here, so I'm going to actually find these, but this is a nice test of our navigation skills, a good practice while we discover some of the interactives. So I'm going to walk through a few of these together with you. The first one is a request to have the book read aloud the first paragraph of section 4.1. So I have to figure out how to get to the first paragraph of section 4.1. Well, if I go to the contents, I can go to chapter 4. And once I'm there, if I hit the chapter button, I know that I can get to the beginning of a section by clicking directly here. So here's the beginning of section 4.1, confirmed with the green title. And hey, look, after every paragraph, there's a little speaker. I'm going to be quiet for a moment and press this, and hopefully you can hear what's happening.
How do we describe speeding up or slowing down? What is the difference between slowing down gradually and hitting a brick wall?
So every chapter in the book is narrated by a human, and we have a recording of that, and that's embedded in the student book, and you can get to it for any paragraph. The students can get to it for any paragraph by just clicking on the speaker icon to have that chapter read aloud. All right. Next one, have the book read aloud the Spanish term and definition for the vocabulary word free fall. All right, so we have to find a particular glossary term or vocabulary word free fall and then see what we can learn with it. I think that might be a good use of our search. We haven't looked at this yet, but the search, if I type in free fall, it isn't a search of the raw text of the book that would have many, many dozens of hits. It is, however, a search of the index of the book. So this is kind of a human curated index. And I might start with free fall definition of on page 122. And there we go. It highlights the paragraph in which that is introduced. And look, free fall is a term in blue here. If I click on it, I can see that it pops open a little window that tells me the definition. I can read that, have that definition read aloud.
Free fall, motion of an object.
And there's a little button here, EN for English. If I click on it, it switches to ES for Espanol or Spanish. And for the vocabulary terms in the book, we have each of them read by a native Spanish speaker and have recorded that along with showing the definition here in Spanish. So,
caída libre. Movimiento de un objeto cuando solo la fuerza que actúa en él es la fuerza de gravedad.
All right, so number 2 here, every glossary term is available as a little pop-up defined in context in both English and in Spanish with both languages narrated. Third interactive we'll look at, a video animation of a cart traveling up and down a track. Well, I know there's a videos button up here, so I'm going to go and, hey, I can go directly to the videos and animations in the book. And in this case, it's an animation. I can just hover over it and see that interactivity in the book through that video. Some of the videos are live action demonstrations, some are animations like this one, but you can get to all of those within a chapter by hitting the video button here, or go to the home page and hit the video button there to see them book wide. All right, now this is a really important one. We have equations throughout the book, and for many of those equations, there's an interactive version, which can have students dive a lot deeper into their understanding of it. So let's find the interactive version of equation 4.3, which is the equation for position in accelerated motion. Let me see. There's no direct way to get to the equations. I'm going to go back and forth a little bit, except one time somebody showed me the following. If I go to the section end, I can get there, for example, by jumping to section 4.2 and going back a page. So here's the section review. Somebody showed me something I didn't know recently. You can actually jump to equations directly by clicking on them in the review. So let me go there. That's 4.3 right there. So there's 4.3 on page 115. And of course, both the physical book and the textbook, the ebook, introduce this equation here. But notice to the left, we have in the sidebar interactive equation. So let's take a look at an example of an interactive equation, which are throughout the book. So here is that equation that we saw in the text, kind of brought to life. It's brought to life in a number of ways. We see the equation here, and then there's a solver built in. So the way we use this is there's always a gray box. In this case, position is the unknown that's being solved for. You can change whichever thing you want to solve for by using this drop down. I'll leave it as position. I'll go ahead and say maybe our initial position is 10 meters. We have maybe a negative initial velocity. I'm interested in what happens after, say, 5 seconds, and let's have a positive acceleration. So I've put these in, and hitting the equal sign, it solves for position based on these inputs that I've put in the white boxes. The gray box is the output. But it doesn't stop there. In this case, it physically animates this situation of going from time 0 to 5. If I hit run, we will see it start at 10 meters with an initial velocity of -2 and accelerate with a positive 2 meters per second squared. And so it really, in the case of things we can visualize, brings these equations to life. To give students additional practice for problem solving, there are problems built into many of the interactive equations shown here, and it gives students practice figuring out, well, what's asked for, what's the unknown, what am I given? So an example of an interactive equation, and they're throughout the book, particularly illustrative here when we have motion equations like we do in equation 4.3. All right. Next one, the worked solution to the test your knowledge question on page 115. This is another thing that's in the ebook alone, and that is on some pages, we have formative assessments for students embedded in the ebook, giving them an opportunity to ask themselves and test themselves, did I really understand this? So in this case, there's a test your knowledge question at the bottom of page 115, asking students to find the baseball's speed if it's thrown up and with a given acceleration and has a certain time to go up and down. The multiple choice answer options are here, and notice there's a show solution button. If I click on that, it gives the correct answer, but perhaps more importantly, if students don't get that, it tells students how to solve it with the actual parameters given here, this equation, assuming these things, and here's the formula. So test your knowledge questions sprinkled throughout the book with solutions presented. All right, quick one here, alternative form of equation 4.5. I'm going to go forward a few pages here to get to equation 4.5. And throughout the book, you're going to see these little buttons called More. If you click on More, sometimes it's related to an equation, sometimes just to text content. It's going to open up a panel that gives you additional information. This is never key content, but in this case, it's a rearrangement of this equation 4.5, and it makes some allusions to something in the future, how this relates to energy in coming chapters. So students who are curious about particular things might want to dive into the more paragraphs throughout the book. One of the authors told me once, this is a 900-page book. It would add about 1/3 of the length if all the more paragraphs were also printed out in the physical book. So a lot of content embedded there and more. All right, 2 more things we'll look at here. One is the number 7, the worked solution to section 1's review question number 3. So to go to the section review, my trick is to go to the next section and go back a page. So here's the section 4.1 review, and the book itself poses these questions, but in the case of the ebook, there are similarly shown solutions. So I can show the solution here, and for this through question number 3, it's quite extensive. Again, answers given and then solution given both graphically and through the algebra. All right. And finally, this is a really good one for students' formative assessment. In each section review, there is a dynamic quiz generator that goes beyond those questions that are embedded in each section review. So I'm going to go to section 2 in chapter 4. And here's the section review 4.2. And we have these built-in problems. And then notice there's an orange take a quiz button. This take a quiz button is going to pop open a never before seen quiz. Now, why never before? Well, there's a bank of questions here, and each time there's a numerical value, it is going to put in a new numerical value that's not just randomly selected, but it's randomly selected from within a range of reasonable values. This is a way for students to practice what they've learned in the section and test that. I'm just going to go through here and randomly pick C just to show you the opportunities presented here. So if I go here, I can choose to score the quiz, and it's going to show me which ones I got right, which ones I got wrong. I only got one right randomly. So I got number 2 right. And if I'm struggling with it, notice it gives me a hint for each of the ones I got wrong. So I could try it again. If I'm really struggling, I can press show solution. And despite this having a numerically unique value, it solves the problem for me using that exact value. So a great way to generate new quiz questions for students to do formative assessment. Some teachers use this by saying, you know what, it shows each attempt. I can try a number of attempts. I want you to get 100% after 3 attempts. And students could then print that off if you want them to show evidence that they've gotten the topics in a particular section. So that take a quiz feature is built in at the end of each section review. All right, so hopefully you can see the additions here of important content in the student ebook. Kel, any questions we should address to the whole group before we move on? Yeah, thank you. I mentioned indefinite number of quizzes. Thanks, Kel. So if we go to the quiz, each time I go in there, there's a new one, different values, a different mix of questions. If you want students to stay in the quiz itself and get a new one, you can press the new button, and each time you do so, it's going to regenerate a new set of questions. Thanks for that. All right. So we're going to move now from the student physical book and ebook over to the teacher resources. There is no teacher physical book, so these are all going to be electronic resources that live in a variety of places. One is the teacher ebook itself. Another are is a resource on our website called the Test Bank, the PASCO Academy, and then we're going to revisit that page we looked at to get students to the book, education.pasco.com, to make sure you know what resources are additionally available there. So we're going to start though in the teacher ebook. How do you get to the teacher ebook? Well, it's the same way you start getting to the student book. By the way, if you've had Essential Physics a while, you may not be familiar with this address. This is a new address. We just, over the summer, Northern Hemisphere summer, changed things over so that both students and teachers go to the same location. But if you have the old links, rest assured they redirect you to this. So if I'm a teacher, I would also go to education.pasco.com, get the same thing that my students see, the opportunity to enter an access code. The teacher access code, though, is unique to teachers. It is a similarly long set of numbers and letters, but in the middle of it, you're going to see EP3 for Essential Physics 3, TE for Teacher Edition. And similarly, this is licensed for a specific number of teachers in a school or district, and it's shared between all of the physics teachers who have adopted the book. So I have logged in on a different browser here. So I'm going to go over here and we will see what it looks like when you do log in as a teacher. You'll notice it looks fairly similar to the student login, but we get some more opportunities. We have the teacher book and then some of these other features that are teacher specific that we'll look at shortly. But I'm going to begin by opening the teacher ebook. And from the start, it looks exactly like the student ebook. Well, almost. There is a test bank button here that we're going to visit shortly or at the end of the ebook. But I want you to know that the things look quite similar between the student book and the teacher book. The navigation buttons are the same. Now, I didn't call these out when we were in the student book, but the student book also includes a standards button and a help button. Let's look at each of these in the teacher version. If I go to standards, it is going to show you the standards. These are correlations between US national and state standards and content in the book. It defaults to the next generation science standards, but you can click on this and go to other states if your state hasn't adopted NGSS. For example, California has. So if I hit California, it shows me NGSS as well, but there are states with their own standards. One example is Texas. And if I go to Texas here and choose select, we will see the Texas TEKS standards. And you can go and filter these. I might be interested in covering friction if I'm a Texas physics teacher. And it will filter those TEKS standards down to that. And the great thing here is that it shows me the type of correlation. This is student book content or assessment questions, and it gives me a direct link. So I can click here. for friction, and it highlights that in yellow. So here is coverage of that particular Texas TEKS standard. All right, so we hope you'll be able to use this. This is available in the student book as well as in the teacher book, but I'm guessing more teachers are interested in it than students. Another thing available from the home screen on both books is the help button. The content is a little different. On the teacher book, it gives you some information, including some helpful videos. Everything I covered and more in the Navigating the Student ebook portion of my presentation is covered in this quick video. Similarly, for teachers only, there is a teacher's edition video that shows you the key components of using the teacher's edition, which I'm about to show you in this short video. There's also a video on using SPARKvue software, links to our technical and teacher support groups. Importantly, there's a whole user guide for teachers. You want to learn more about a particular feature of the book, it's covered in this extensive PDF user's guide that's linked to from the help section of the teacher's ebook. There's information on getting to SPARKvue help, and otherwise some good resources in the help button for both you, the teacher, and students. The actual content in each of those buttons varies a little bit as appropriate for students or for teachers. So I'd like once again to use chapter 4 as a good overview of the content that's in the ebook for teachers that's not in the student ebook. So I'm going to go directly to Contents, Acceleration, chapter 4. And here we see the main characteristic that distinguishes the teacher book from the student ebook, and that is sidebars. These yellow sidebars contain the additional information to help you, the instructor. It'll give you overviews that aren't in the student book. So here's a chapter overview. And crucially, on the first page of every chapter, it's going to talk about what lessons are in this chapter. Now, the concept of lesson is unique to the teacher ebook. We saw that the student ebook had units, chapters, and sections. In addition to that, there are lessons in the teacher book because lessons may sometimes span more than one section or be just one subsection. So we have lessons as the key component, the fundamental unit of the teacher book content. Now you can go to the lesson content itself by clicking on these thumbnails. So if I want to go to the beginning of lesson 1 in chapter 4, I can click on it. It jumps me to page 108. This is where lesson 1 begins. And now we can take a look at what comprises a lesson in the teacher ebook. Well, a lesson has a particular summary. A certain number of pages are in this, and then it shows you what some key content is. Most importantly in this case, though, are what resources do you, the teacher, get for the lesson. So I want to spend some time covering these. One of the resources is a lesson plan. I'm going to open up the PDF, but this is also available in an editable Word doc format. If I open up the PDF, we'll see that every lesson in the book has a lesson plan. All right, what is the content? What are the objectives? What do students need to know coming in? And what are some ideas for introducing this for various types of learners? How can you assess whether students have gotten it or not? And then some prior knowledge, key equations, and so forth. So every of the 80 or so lessons in the book is going to have a lesson plan. Here we see the PDF version of it. Next up in the resources along the side here for this lesson number 1 in chapter 4 is the slide presentation. Once again, I'm going to open the PDF just because it's easy to present here in the browser, but I want you to know that there's also a fully editable PowerPoint. If I open the PDF, you will see this particular lesson has 77 slides. We try to err on the side of giving you more than you need because we give you the PowerPoint and you can edit it down and change it as necessary. So here is a set of slides that you can go through as students or borrow from for your own presentation style. You can add to, subtract from this because it is also available as a PowerPoint. So another resource to guide students through this lesson. Next up, every lesson has an assignment. It may be an assignment that is an investigation related to hands-on assignment, or like this one in lesson 4.1, it is just an assignment that is available to have students begin working with accelerations. So concept of acceleration. And the PDF is the first version I've opened of this. Typically, if you're working on paper, you could print this out for students. If you want them to be electronic, you'll notice that we've made the PDFs into forms, so students can actually type numbers into these values into them if you want. Now, this works pretty well until you get to needing to draw. Many schools have drawing solutions like Kami for drawing on PDFs. But if you don't, we also give you The student work in an editable Word document if you want to tweak it or distribute it that way, and also as a Google slide. The nice thing about Google Slides is that not only can they accept text, they can also accept drawings as described here. So the way you'd use the Google slide if you wish, especially if you're a Google Classroom, is that you'd log into your Google account, you could go to File, and you could make a copy of this into your own Google Drive, tweak it if you want, and then distribute it using the mechanisms that you use to distribute Google documents to your students. All right, finally, there is an answer key available as a PDF or a Word doc for the student work, no matter the form of that student work. So that's an example of the resources available in the sidebar of the teacher ebook for a lesson that doesn't have an investigation. I'm going to go forward. Well, actually, I'm going to go back to the beginning of this chapter so that I can jump to the example of the lesson that has an investigation. This is lesson 2. And if I jump forward there, you will see this has an investigation 4A. Now, many of the lesson resources are the same. We have a lesson plan for this. We have a presentation. I'll note one nice thing about the presentation when it does have an investigation is that somewhere through here past the content, it will have slides that you can use and present to students that tell them the key points of the lab itself. So in this case, they need to determine the acceleration from a slope of velocity graph. If they've never done that, here is a slide you can show them. Step 1, in SPARKvue, click on this, step 2, and so forth. We're going to get to doing some of these, but I want you to know these resources are available for you in the PowerPoints when there's an investigation. In the case of this investigation, the student work is an assignment, but it is the investigation itself. We saw this in investigation 1A, an example of instructions with a place for student responses. There is the answer key. And then for most of the investigations that use PASCO equipment in the book, there's also a teacher-to-teacher video. So I'll open this briefly, and you'll see that we have a master instructor who is not doing the lab, but they're talking to you about the key points of the lab. This video is sectioned.
What is acceleration and how does it relate to speed?
There's an introduction. There is a description of the materials in need, including alternates. There is a section that shows or describes key points of setting up the lab. And then there's an example of doing part 1 and part 2, any key parts of that. So this isn't the entire performance of the lab, but it is, as one of my colleagues described, it's that master teacher who has experience spending 5 minutes with you saying, here's what you need to know to do this investigation. So those videos are throughout the book for those investigations that use PASCO equipment. All right. So we've taken a look at the sidebar resources for lessons. There's one more place in the book we want to look for sidebars, and that's when we get to the end of chapter problems. If I go to the end of chapter 4, we of course saw the problems in the student version. In the teacher version, the answers to the solutions for those questions are in the sidebar. And I also want to point out that whenever you see italic text, there's additional information embedded in the question itself for teachers that's not in the student book. So those are some of the key components of resources built into the teacher version of the ebook. We've seen that there's a chapter overview with the sidebar linking to the lessons. At the start of a lesson, we will see the lesson resources here along with some key points. Lessons with investigation have similar content, but often have that video. And then finally, the chapter review problems have solutions in the sidebar for you to help in grading. All right, Kel, any questions about the teacher resources before we move on to things outside the book for teachers?
Can we buy just the teacher versions?
Yes, indeed. So the question is, can one buy the ebook and ebook teacher versions? Yes, yep. We have some resources available for you on the education.pasco.com page. I'll show you a link where you can get more information after that. But there are different permutations. You can determine what number of books, student books you need, physical books, ebooks, teacher versions, and so forth. So yes, it's all customized for your particular adoptions needs. Great, thanks for the question, Marie. All right, so let's move on to other teacher resources that aren't in the book proper. First thing we're going to look at is this infinite test bank. First question is, where do I get to it? Well, there are 2 places the teacher can get to the infinite test bank once you have teacher book access. One of those places is directly from the launch page, education.pasco.com. We've put a test bank icon there directly. Alternatively, if you're in the ebook itself and go to the homepage of the teacher ebook, you'll see that there's a test bank link there. Both of these lead to exactly the same location. Let me go ahead and click on it now. And I want to first tell you that I'm already logged into the test bank. So let me show you by slides what you will see the first time you get to the test bank. And that is, it's going to say, welcome. You're not going to be able to see this unless you have a teacher book login. So it is secure from student eyes. And if you haven't already logged in, you can either put in a user key if you haven't already, or get your user key. The way you get the user key is to simply type in your email address, press create. A few moments later, you're going to receive an email with that code, and then you can just paste it in here into the user key and enter. And thereafter, the tests that you create will be associated with your test bank user key, and you can revisit them month after month, year after year. So as I mentioned, I've already created my unique user test key, and I've entered it. So once you do that, you will get to this page when you go to the test bank. And we have a choice between our two textbook programs. We're of course talking about Essential Physics today. So I'll go into Essential Physics and let's see how we can use the Infinite Test Bank to design, say, a Chapter 4 exam for the end of the chapter. So I'm going to begin here by saying I'm going to make a test for my honors physics class. Despite what this says, I find this field more useful to be the description of the test. So I might call this the Chapter 4 exam, and I'll put my name here. These things are going to appear on the tests themselves. I have a choice of what difficulty questions I'd like, and then a choice of where I'd like these to come from. Since this is Chapter 4, I'll open up Chapter 4 on acceleration, and I see that if I choose all 3 levels of difficulty, I have the option of choosing from 16 question types for Section 1 on acceleration and 9 questions for Section 2 on gravity and freefall. And as I change my desired levels of difficulty, you'll see the number of available test questions changes. So let me say I'd like all levels of difficulty, and I want this test to comprise 6 questions from Section 1 and say 4 from from Section 2 rather. I'll go down now and continue. And in the next step, it's going to preview the exam for me. So I can see that, well, here's the first proposed question. If I like it, I can just leave it there. If I want to make it easier, I think maybe difficulty 3 is not a good way to start. So I'm going to say substitute an easier question. That looks better. I can change the order of the questions. I can swap it out for other questions. I can delete them if it's not appropriate. But basically, it has generated the requested 10 question test, 6 of the questions coming from Section 4.1, 4 of them coming from 4.2, and a mix of difficulties. I can see here the average difficulty is 1.6. That is giving easy 1, medium 2, and difficult 3 points, and averaging that out. So if I'm happy with this test, I can go ahead and build assessments. Now I want to note here, this isn't the test itself. You're going to see in the next step, when I build assessments, that basically this is an infinite test bank in the sense that now that I have the question types, I can go in and say, you know what, I really do want a different test for my first period honors physics than for my second. And I can generate was it up to 30 different tests based on the template that I've just created. So I'm going to create 2, one for period 1, one for period 2. And now when I actually press build assessments, it's going to take that template that I generated with those 10 questions, and it's going to create 2 different tests. I can preview them here where I'll see that, yes, both of them talk about question number 1, dropping something off the Eiffel Tower, but they use different numbers in each case. So they, of course, have different answers. So a way to have the same concepts covered, but have different solutions based on your needs to distinguish between test groups. So what I can do here is I can change the name. I can print the tests themselves. All right, so if I'm ready to do this, I could print it to a PDF or print directly to a paper copy. If I was using paper copies, I'll also note that this works pretty well for copying and pasting into Google Docs and Word if you want to tweak it further. There's a solution set. So if I want to quickly grade my period 1 test, here is the solution set. And hey, if I want to provide full solutions to students to help them fix their mistakes, here is the full solution set for each test with those unique numbers used in that test. Finally, if you want to bring this into your own LMS, we have the ability to export QTI format of each of these tests. And finally, you can delete them if you no longer need them. So if I go back next year and say, you know what, that Chapter 4 exam worked pretty well in 2023, I can generate additional tests for 2024 and so forth once I have this template. So a quick overview of the Infinite Test Bank. We hope it's a great tool for you to generate variable exams for your students. Kel, did we get any questions we should respond to? Nope. Okay. Thanks for answering those in the Q&A. All right, so we've seen the test bank, its ability to generate tests. Another resource for teachers just outside the ebook. It's available via education.pasco.com, and this is the PASCO Physics Academy. So if I head back with my teacher login to education.pasco.com, I'll see this Academy button. I'm going to follow this to get into the PASCO Physics Academy. So the Physics Academy is basically a set of 25 topics spanning the textbook and a typical one-year physics course in high school, from lab skills to kinematics, all the way here to thermodynamics. And you notice that each of these is associated with one or more investigations from the book. So the first one correlates to investigation 2D and so forth. So that's the layout of the academy, but more importantly, what is the components of each of these? So I'm going to go into maybe topic 17, sound. This is associated with the textbook's investigation 16D, gives a summary here, but let's actually dive into it and see all the resources available in the Academy for topic 17, sound. So here are the resources for topic 17. We have some background, a summary of the investigation and the resources. We see that it corresponds to a particular single lab in the book, 16D. It hyperlinks to the pages that are relevant. And then probably the key component of the Academy is a set of 3 videos. So I'm going to talk about each of these videos in turn. The first video is, once again, a teacher-to-teacher video. If I launch this video, this is a teacher preparation video that is our master teachers talking to you, another
Welcome
teacher.
back to PASCO Academy. This time we're doing Lab 16D.
And typically these videos run probably 10 to 15 minutes. The first half of them are an overview of resources, both in the book and sometimes outside the book, that you can use to succeed at doing this investigation. And the second half is an overview of the components of the lab, along with advice for administering it, variations on it, and so forth. So this is a teacher-to-teacher video orienting you to how to cover, in this case, investigations 16D. All right, that's the first video, and that might be enough if it prepares you to do the lab with your students. However, there are times when you may not have the equipment, time, resources. You may not be present to do the lab. In that case, video number 2 comes into play. This is a video of our instructors talking directly to your students. We give you the URL here so that you can copy the URL and send it to your students if you want them to view this lab being performed. Some instructors use this as a pre-lab, others use it as a lab substitute, depending on the circumstances. I'll mention this was created during the height of lockdowns in the pandemic, so you can see the impetus, but many teachers have found uses for it in absences. When the students are absent, they can make up a test by viewing this. When the teacher is absent, your substitute may still be able to do the lab by presenting this. So in this case, this is those same instructors talking directly to your students.
Welcome back to PASCO Academy. This time we're doing Lab 16D.
Introducing the topic, usually through some interesting background information, and then actually performing the lab. Here's data collection part 1. Data collection part 2.
We make measurements, so we have the tools to make the measurements, so we know exactly what we're working with.
And helpfully, the exact data that is being collected here in this student video is available as a download. So if this is substituting for doing a lab, the SPARKvue file that corresponds to the data collected in the video is presented here in the sidebar of the PASCO Teacher Academy. Now, we hope you're doing hands-on whenever possible, but we know that's not always possible. So that's why the student data collection video exists. If you're also not able to follow up with the students, maybe they were absent for a week and you already passed the follow-up for the lab, we also have a video that talks from our instructors directly to your students, taking the data that was collected and answering the questions in this investigation with them alongside them. So typically, if you use the student follow-up, it would not be presented to your students until after they've handed in their work. So duplicating things that are in the book, the student handout for 16D is also here, and in all 3 formats, PDF, Word doc, and slides. And then because this video shows specific data collection, we have a new answer key that's distinct from the one in the book, because this is the answer key using the data that was collected in this video. So I'll give you some resources there, an example of what the components of a topic are in the Academy, and some ideas about when those are useful. So teacher orientation teacher preparation video. And then those times when you or the students can't connect, you need to do something asynchronously, or you don't have equipment, the student data collection is a direct talking and presentation of the data collection for an investigation from our instructors to your students. So I see Cal answering some questions there about the Academy. If you have any Academy questions, please do let us know. I'll note that the Academy just won the Best of STEM educators pick for video-based learning this past year. All right. We have 20 minutes left. We're going to spend a couple minutes looking at the additional resources available at education.pasco.com, and then we're going to sum it up by actually doing an investigation on Newton's second law so we can see how all of these resources come together. I'm going to go directly to education.pasco.com here and just call out a couple of resources. We've already seen the resources that are available by logging into that page to get access to the textbook. But if we go back here, logged in as a teacher, I of course see those direct links, but the rest of this page is at least visible to everybody. There'll be a summary of Essential Physics 3rd edition. The standards and correlation are also linked to directly. If you want to learn more, Marie asked earlier about product details. If you follow this link, it goes to our product pages and you can get a sense for the components, all of which can be remixed as needed for your particular adoption. We have some video guides. So we saw video guides inside the book on the help pages. Those are repeated here. To be honest, the over 60 minutes we spent together are very densely condensed in these short videos on navigating the student ebook, which would be a great way to get your students familiar with it, using the teacher edition resources, and also one on using SPARKvue software, some of which we'll cover shortly. Now, SPARKvue software is available across most platforms that are used in education these days. It is a free app linked here to the Apple App Store for iOS and iPads. It's available for Android tablets and phones on Google Play, and also as a free app for Chromebooks. All are linked here. Slightly different, but functioning the same, SPARKvue is available on Windows and Macintosh computers, and you'll need a licensed installer to get the full version of SPARKvue on those. But if you've logged into the textbook, either as a student or a teacher, these have direct links for downloading them. Now, of course, you need to figure out in your district who has the rights to install what, but those licensed installers are available here to students and teachers as long as they are logged in to the page at education.pasco.com. And finally, more information about the equipment kits that let you do hands-on activities with Essential Physics are here at the bottom of the page, linked to more information about those kits. So additional resources here at education.pasco.com. All right, so I'd like to pull it all together. If you have access and you've watched this webinar and you have the equipment, I'd suggest pausing right now if you're viewing the recording and asking yourself and challenging yourself, are you ready to do investigation 5A, Newton's second law? How would you start? Where would you find answers to the questions you don't know? And we, of course, are going to do this together live now, but let me suggest you pause if you have access to the book and think about, summarize what you've learned so far. Let's go ahead and start on this journey. Let's figure out how would we and our students do Newton's second law, which is investigation 5A. Well, if I were the student, they would encounter it in the book. They could go to investigations, and we get to 5A. All right, here, of course, are the basics of the lab. With the questions here, this might give a good overview. It might be assigned as a pre-lab, but we know from the coverage we just did and that there's more content available here for students in the teacher ebook. So I'm going to switch over to the corresponding page in the teacher ebook. Again, this is now the teacher ebook. If I go to that same investigation, we know for sure that along the sidebar, we're going to find some resources. Something slightly unique here is that we've had various equipment kits over the years. You may have this equipment kit or this equipment kit. In either case, we have student work uniquely describing how to use that kit. But of course, we have a lesson plan for setting the context of students doing Newton's second law, listing the equipment. We have a presentation, and we have that crucial video. So I would often start with a video here. Here is a 6-minute video.
How is an object's acceleration related to
teacher to teacher saying, here's what you need to know about doing this lab. So let's assume we've watched that video. We're ready to assign the students the handout for this. Here is the student handout for investigation 5A. And now together, let's start walking through this. And as we go, think about the things that you don't know yet. Is this asking us things that we don't know? And where would we look for answers to that as the teacher to help our students work through this lab? I'll also note that this is 5 chapters in, so students will have covered some of these things already. This isn't an hour and a half into their course, but of course, we want to support you whether this is the first lab you're doing or the 10th lab you're doing in essential physics. So it asks students to open the file 5A. We learned earlier, and there are of course resources in the book that let us know that, hey, this is something we can get to. It's built into SPARKvue directly. So let me relaunch SPARKvue to start fresh. This is going to bring us to the welcome screen, and we know to look for essential physics template or investigation files inside the open PASCO experiment, essential physics, and this is investigation 5A, Newton's second law. All right. In this case, we come to a dual graph, velocity versus time on the top rather, and force versus time on the bottom. All right. So next step, connect your smart cart using Bluetooth. Let me switch over. This is the smart cart we're going to use to save some time. I've set some things up. So I'm going to turn on this blue smart cart that's on the track. You can see in the live video, and we know to connect to it by clicking on the Bluetooth icon, identifying our cart by its 6-digit ID, connecting to it via Bluetooth. And again, there are slides in the teacher slide deck that have these steps illustrated for you to present to students if this happened to be the first time they were connecting to a smart cart. All right, crucial here, in your software, zero the smart cart force sensor while nothing is touching the hook. Now that's something that is probably not something students have done up to this point. So I'm going to go over here and make sure nothing's touching the hook. I've set up the equipment otherwise. We have a smart cart with some masses on it on a level track. There is a pulley at the end, low friction pulley, and I have a string with a hanging mass. So I did that ahead of time, but it's illustrated in the student handout there. How do we zero the force sensor? Well, if I remember that the teacher version of the book has, well, it's covered in the video for one, but there's also the PDF here, and I'll say zero sensor to get to it quickly. And hey, here's a slide that you can project to students saying, hey, here's how you get to that. When you get to the step, you unhook the string from force sensor and press these buttons. So no force on the smart cart's hook, zero sensor now, and now it reads about 0 newtons. So that's accomplished. Back to the instructions. Pull the smart cart to the end of the track after reattaching the mass. All right. String it over here. We have some masses on the cart itself to give it a little more mass. And as instructed here in the student instructions, on the hanging mass, I have the 5-gram hanger and I have a 20-gram cylindrical hanging mass. So that's described here. And now it's asking us basically to release the cart and record data of the cart rolling freely, being accelerated by that hanging mass, and do it for 5 trials, adding a different mass each time. I open the instructions for the different set of equipment. Here we can say it's specifying the 20-gram masses. So let me switch over to SPARKvue. Instead of collecting 5 runs, I'm going to quickly collect 3 just so we can get some representative data. So here's with 20-gram mass. All right, stop. And now the student instructions say add another 20-gram mass and repeat. And you can see the data collection itself is going to go fairly rapidly, but we're going to curtail it with 3 runs just so we can focus on the more novel thing, and that is how do we analyze the data. So here's our 2 20-gram mass run. This will be run number 2 in SPARKvue as indicated by the thing we call the graph legend. Run number 2. Up. And I'll add 1 more 20-gram mass for trial number 3. One thing you'll be noticing is that SPARKvue's graph by default shows us only the most recent run. But if you look in the upper right there, you can see the legend indicates that, hey, those other prior runs are available. They're just not visible. And we'll learn when we get to analysis and how to make those visible. So our final trial we'll do together. Start and stop. All right, so we have our 3 runs, 3 of the 5 as instructed. And now it's asking us to, for each trial, find the cart's acceleration as the slope of the velocity graph and the average net force on the cart. So while it was rolling freely down the track. All right, so there are slides to help students understand, well, what is rolling freely? What does that region look like? But we're going to dive right into it here in the little time we have left, so we can make sure to cover some key SPARKvue visualization and analysis skills. First thing I've already mentioned is that is only one run. The most recent run is visible at a time by default in SPARKvue's graph. We can change which run or runs are visible by clicking on the checkbox to the left of the run name in the legend. That checkbox is a visibility checkbox, and you can see when it's checked, it's visible. When it's unchecked, it is available but hidden, so that it's not cluttering the screen. So we have all 3 runs here. I'm going to go ahead and start with run number 1, and it's asking us to analyze 2 things. One is the acceleration by determining the slope of our velocity time graph during this portion when it's rolling freely, and the other is the average force applied directly to the cart. This particular lab is nice in that it uses the force sensor built into the smart cart, so that students don't need to be worrying about what's the system here of masses plus cart. It's measuring directly the force applied to the cart and the resulting acceleration, keeping things simple here, a simpler system. A couple things to know, in SPARKvue, we can change our view of the data. We've already seen that the scale to fit button automatically rescales the axes of the graph, but we can also do that manually. If you want to, with this hand switch selected, you can just click and drag in the middle of any of these plot areas and move it left, right, up, or down as if it's a piece of traditional graph paper on the tabletop. Now, you can also scale it. So if I were only interested in looking at the region when the cart was rolling freely, I could move it to the left and scale it manually by grabbing a number on the x-axis and just dragging it out. And I like to think this kind of works like a rubber sheet of graph paper. If it were made of rubber, I can stretch it and compress it, all relative to the origin. And that same technique works for numbers on the y-axis of either plot area. All right, so on to the analysis. It's asking us to find the acceleration of the cart. We have a velocity versus time graph. When we want to find acceleration, we often, over a span of time, we often use a linear fit. And there's a dedicated linear fit tool. It is this button in the graph toolbar. I'm going to turn it on, and it's going to do its best to do a linear fit to what? Well, it's the entire set of velocity data for run number 1. That's why this best linear fit line doesn't quite match what I was hoping it would match. But the reason for that is understood. It is just analyzing the entire data set. If I want to analyze only a portion of the data set, I'm going to go back to this switch down here that toggles between move mode and select mode and put it in select mode. And now I can draw a box around the data points I'd like to analyze with my linear fit, and you'll see that it adjusts, and the linear fit applies only to those data points inside the box, and I can adjust the location and size of the box after the fact if I want to. So from this, I can see the slope of velocity time is acceleration, and that value is 2.52 in this case. So if I were working with the student handout here, I could say, you know what, the acceleration for trial 1 was 2.52. Now the next thing we need to analyze is the net force while the cart was rolling freely. All right, well, average net force it's asking for specifically. So we need to focus now on this lower plot area. We can see the force here varies a little bit, maybe as the mass was swinging, but we get a pretty representative force here. Now, there are tools that we won't cover today that would allow us to analyze particular data points. But before we look at those tools, we need to see that there's only one graph toolbar, yet there are 2 plot areas. And SPARKvue needs to know which of these 2 plot areas we want to analyze with these tools. Now, it just so happened things worked when I wanted to analyze this one. But the reason it worked is there's only one active measurement and run at a time. And by luck, it happened to be Y1 velocity for run number 1. If I want to analyze lower plot area here, I first simply need to click on it. It becomes the active measurement and run. And now these tools will apply to it. One of those tools would let me find particular coordinates, but it's actually asking for the average. So instead, I'm going to go to our statistics tool with the Greek letter sigma. I'll turn on the mean calculation. And once again, it's doing the mean for the entire data set. So we already know how to do that. We make the selection active. And now you'll see the mean updates. So it's analyzing only those highlighted data points. So it looks like the mean force, mean net force in this case was 0.250 newtons. All right. So we now know those two tools, those techniques, and the importance of making an active run. So I'm going to proceed now to run number 2. I'm going to make the velocity data active, and I'll very quickly go through and say, you know what? I know I want a selection. I can actually start by making the selection if I want to, and conveniently that linear fit tool pops up. So this I find to be a little bit quicker. So there's our acceleration, change what's active, highlight, there's my statistics tool mean. So let me quickly go through and record these values, 0.426 newtons with a corresponding acceleration of 0.497 meters per second squared. And we'll do one more run of the 5 requested. This is run number 3. Similarly, make a selection, linear fit to get the acceleration, 721 meters per second squared. And make the lower plot areas measurement active. I'm going to scale it a little bit here, move it over by turning the hand on. And now I can make a selection in this region, turn on statistics, mean, and the average net force was 0.595 newtons. All right, so let's say we collected all the data we need. The next step for students is go to the second page of the experiment file and enter this data. So ultimately, students are going to be asked to make a graph of the net force for each trial versus acceleration and see if there's a trend there. So let's go to page 2. We can navigate different pages in SPARKvue by clicking on this forward arrow. We can see there are 2 pages in this particular SPARKlab file. And now it's basically asking us to enter those net forces and accelerations that I and perhaps the students wrote down earlier. So let me quickly type these in. 250 newtons, 426, 595, and the corresponding accelerations for the 3 trials we did, 252, 497, 721. All right, and we see this plot being constructed on the right, and students are ultimately going to be asked to sketch that and guess what sort of relationship this is suggesting between net force on the y-axis and acceleration on the x-axis. It's beginning to look linear. It'd be great to have more data points to do so, but with the data points we have, I'll go ahead and do a linear fit, and we can begin as a student to answer questions about what the meaning of these linear fit parameters are. And just to cut to the chase, when students are asked to compare the slope of the net force versus acceleration curve to the total mass of the cart. This cart is about 250 grams, and I have 2 250-gram masses on it. So the cart mass, if I put it on a scale, would be approximately 0.75, and we can see that that slope is pretty close. Hopefully get closer as we get more data. So that was kind of a whirlwind tour through a particular investigation, an important one, Newton's second law, but I hope it gave you the sense of the incorporation of investigations in the student book and the multiple resources that are available to you as the teacher to support that. Now, let's say one student, Charlie, was absent and needed to make this lab up. Where would you look in that case? Well, Charlie may have a lab group from which they could get data, but if you want them to kind of do something unique, remember, of course, we have those teacher resources that are in the book and those that are outside the book. So if we head back to education.pasco.com and go to that academy, we'll see that, of course, Newton's second law, one of those key labs, 5A is here. Here's another teacher orientation video. Here is a student data collection video. I could copy and paste this link, send it to Charlie and say, Charlie, do this lab. Here's the handout, finish that. And if you have no time to grade it, you can simply point them, Charlie, to this particular video for follow-up if you need to. So hopefully it's another example of the resources available. By the way, if you just need to pull some data, here's a full set SPARKlab with all 5 runs of collected data, which you may use in conjunction with the student video or may not. All right, let's take a moment to breathe here and see, Kel, are there any additional questions that we didn't address? I see you were actively answering them. Thank you for that. Thank you, everyone, for joining us today and asking those questions. I want to leave you here with a resource for more information. There were some questions about the logistics of getting this system. Can you get textbooks separate from ebooks, so forth? Please contact your local PASCO regional rep. We have reps across the United States and across the world, and you can find your local rep, whether in the US or worldwide, by going to pasco.com/support. Point your phone at this QR code, it'll get you there directly as well. You can then choose your country and region within that country and get the direct contact information for your PASCO rep to ask more questions. If you are a current user of essential physics and you have any technical questions, this same address will get you to our friendly tech support group as well. All right, well, with that, I'm going to stop the recording.